Well, hi, and welcome to my shop, and thanks for joining me here. It's just near the end of May. It's the 28th of May today, and I'm starting work on this Loewe Opta radio, another German radio. My gosh, I've done one German radio after another here for the last couple of months, and these can be very challenging. But look at this one. This is just fantastic looking now. A lot of these have beautiful cabinets, but many of them are cracked. They have long longitudinal cracks in the coating. This one just looks beautiful. Look at that. Minor stuff. The front of this is a great looking radio. I just love the look of this thing. It's all kind of soft, and all the corners are round, and there's no sharp corners anywhere. All the buttons are round and everything. It's really nice, and I like the print. I like the print in here too. It's a little hard to see in the camera. Maybe we can get a little closer here. Really nice. It's a Bella Luxus. Bella Luxus Hi-Fi 3-bander, 3 bands, broadcast, shortwave, and FM. How many pointers? So I see a pointer here, and I can see another one up here. So it's got 2 separate tuning pointers, probably 2 separate tuning knobs. Let's try. We'll see what happens here. Oh, both knobs want to turn here. Something not quite right there. So this is moving, but this guy doesn't want to move. So the FM pointer is stuck. Okay. Has a magic eye. Just looking this over very carefully. Is that a word right there? Loewe Opta. What does that say? Nothing. That's just a design. It's not a word. Okay, fantastic. Let's go around the back. Often these radios have a fair bit of information on their backs. Let's take a look here. Pull out the FM antenna. Boy, it does not want to come out. Not been out for a while, perhaps. Back. Let's look at the power cord first. Make sure it's not damaged. Looks just fine. No sign of cracking or anything. Feels quite flexible actually. It's good. Loewe Opta Bella Luxus. Type 571W. Now I think the W means it was made for the West. I think that's what that means. I'm not sure though. And we've got some inputs here. We've got like an outdoor type antenna would go here. A lead to an earth ground would go here. The FM antenna, which I just removed, goes here. I can see they're showing it as a dipole. Typically these radios have fairly well engineered antennas in them, FM antennas in them. This looks like the input for a record player. This would be for an external speaker. Here's the tube layout. And what do we got in there? We've got an EL84 output tube. That's good. That's good because it's not that rare. These are typical tubes. EABC80, EF89, ECH81, ECC85 FM tube, and the tube at the front. What's that say exactly? ECC85 and EM80. So the EM80 is probably the magic eye tube that's back here. It's got opening things they seem to be missing here. It's got a couple of screws in it. And we take the back off. Now, I believe the owner, when he dropped this off, it was just yesterday. Yesterday or the day before. I think he told me it doesn't work. Plugged it in and nothing happened. I think that's what he told me. Got nothing out of it. Let's take a look inside. We'll see what's going on. Now, I believe this is a family radio, an heirloom, coming down, I believe, from his grandfather. So it's been in their family the whole time. There's no mystery about where it's been. Open. Well, maybe there's a lock in there. I'm not quite catching on to. Out. There we go. Out she comes. What's written on the inside? Nothing in particular, and that's how these locks work. Haven't seen any quite like this. Okay, away goes the back. What do we got happening inside? Well, I can see all the tubes. They all seem to be there. 1, 2, 3, 4. Should be one more FM tube. I think it's up in there. Yeah, I see it. Okay, good. And the magic eye's bound to be in there too. Yeah, I can see that one too. Good. They're all in here. They're all in here. So if I sound a little funny at times, I seem to be kind of jerking around a little bit. I've got a knot in my back, which is causing me some sudden pain now and then while I'm standing here. So if I kind of jump, that's that's what's happening. Okay, well, I don't see any problem with plugging this in, except I need a plug for that. Okay, we're going to plug it in and see what it does. Okay, so since this is the first video in a series, it could be you are a new viewer. So another thing is I forget what I'm about to say on these videos. Just beware that I really don't know what the outcome is going to be when I'm doing these things. I don't know. We will see. So, I can power this up quite safely, even if there's a problem in it, because I have ways of restricting the amount of power that'll be delivered to the radio. One way is using this device, but I don't do much with this actually. I tend to use what's called a dim bulb system. It's not much of a system. So I have a couple light bulbs here, and by throwing my control panel switches correctly, this one in particular, I can make the power that reaches the radio go through those light bulbs on the way. And what that does is, if there's a short circuit in here, then these light bulbs will prevent a huge flow of current, my house circuit breaker operating or anything like that, or the radio catching fire, which is really, really the effect we don't want. So that makes it possible for me to start up something like this without too much worry. So this is the volume. This is pretty stiff. This is probably a tone control. Volume, tone. Yeah. So we'll just leave the tone kind of in the middle. Put the volume just up a wee bit. We're going to first make sure the set is off. Which it was not. It is now. We're going to apply power and nothing at all should happen. Well, thumbs up on that. So One thing that has happened though is there is voltage right at the outlet here. Now, I also use an isolation transformer, so there is no ground reference. I cannot get a shock from this radio through my feet into the ground, and not just because I'm using an isolation transformer, but also because I'm wearing rubber-soled slippers. I'm standing on a rubber-backed mat. So what I'm trying to say is, it may not look like it, but there's a lot of things going on to make sure I don't get a shock here. 120 volts sounds a little high. Let's just put it back closer to 117, which I think is kind of the North American standard voltage. There we are, that's good enough, 118 or so. Okay, I'm going to cut the power. I'm going to push the broadcast button. Turn the power back on. Now, what should happen if the radio is operating normally is there's a bit of a rush of current into the cold filaments in the tubes. So that rush lasts only a second or two, and during that time these lights will be quite bright. So they should come on quite bright. The current rushes in, the tube filaments heat up, resistance goes up, the current goes down, and the lights go down. Now once the tubes have heated up completely, their cathodes have heated and the tubes are beginning to conduct, especially the rectifier tube, if there is one in here. There probably isn't. There's probably a solid state rectifier in here. Once that happens, the radio begins to draw more power and the light should come up again a little bit. So it should kind of go like this, down, and then after 5-10 seconds, up. We see that, we know a whole bunch of stuff is operating properly. At the same time, we can watch for the eye to come on. Let me just douse the light a little bit here. And that'll tell us a little more about it too. And then we're listening. What are we listening for? Well, hopefully the radio works. Quite likely what we're going to hear is a hum. Or if the owner was correct, we're not going to hear a darn thing out of this. Okay, so we're on broadcast, volume set. Here we go through the lights. Well, not a lot happening here. We have all the voltage here, 117. Don't think this is drawing anything at all. It's possible it is, so I'm going to pull this out and just watch. And would you say that went up a little wee bit? Let's put it in again. No. House voltage going up and down because of other things going on, including my neighbors vacuuming their house and everything like that. Power off. Absolutely nothing. The owner is absolutely right. Nothing happened. Nothing at all happened. There's a really good chance that we can start right away with the fuse. There's the fuse right there. So we're going to pop that out. Let me just make sure I follow my own safety procedures. Even though the power is off to the outlet, I like to know before I stick my fingers on the fuse like that. Let's pull that fuse out of there. Cap is loose. Can you see me pulling it? Yeah, I think this is a blown fuse. So that's the number one problem right there. What size fuse? Now, usually they're going to say that somewhere. They're going to write it on something, somewhere where you can find it easy. Serial number. Well, that's a weird thing. Feels like glue there. Well, it'll say right on the fuse. It may say right on the fuse. Let's look and see. Better to get it out of a schematic or something like that. And because this could be the wrong size fuse. Not likely, but it's possible. It's pretty rusty. 250 volt. It's terribly rusty. The whole thing is ready to just drop apart. So let's look at this with a close-up camera just so you can see what kind of fuse we're dealing with here. So you can see inside looks like a spring, and that's exactly what that is. And the idea that this is a slow blow fuse. It will blow on fairly low current if it runs long enough on this fairly low current, but at the same time you can sneak a heavy current through it briefly, especially when it's cold and you're right at the start. And that's what happens in these radios, right? You turn them on, there's a fairly heavy current. You have to let that get through. And then afterwards you become concerned about similar currents in the radio, which would indicate something's gone wrong. So you got a fuse here that's got to skip the initial blow, catch it later. Now, what about on the back? Sometimes maybe I missed it. On the back here, does it say? Somewhere it's got to say what size fuse that should be. So serial number. There's nothing on here that's going to help me with that. Okay, once in a while these radios have fuses in the high voltage line. Maybe some of the bigger radios. I think this is just in the power line. It's not a high voltage one. Sometimes these radios have 2 and 3 fuses in them, but that much bigger. I think much bigger. By these radios I mean German built or European style radios. Kind of how we can look at it here. We're going to have to just guess. That doesn't make sense that they would leave you to guess. Let's look again and see. Just what I'm going to do here is, come on computer, is I'm going to set the focus as close as I can on that little camera, and we're going to try to read what's written on it. Okay, let's try again. Pretty heavily corroded. Get the lighting right here. Now the 250 part is pretty easy to read. That's the voltage rating. And it's probably got a type because it's a slow blow, so maybe I don't know, type H, I don't know what that is. And then there's the value. I really could only guess 1.2, 5, 2.5, 2.5. There's a 0, 2,500. Okay. That's not helping. We're going to have to reason this out. Does it give a wattage rating on the back here? How many watts this guy uses? He gobbles up no word on it. It doesn't say. I could stop now and just take a look for a schematic. I think I'm going to need one anyway. So I think I'm going to do that. Stop and see if I can find a schematic for the Loewe Opta. Okay, here's a half of the schematic for the radio. This is a Sam's PhotoFact. I got this from Radio Museum, which I am a member. And just another warning here, I am doing these things essentially live. I have only what's in my head available, so as I analyze things, I often, well maybe not often, but sometimes I get things wrong, or I pick bad words I shouldn't be using to describe stuff. So, you got to keep your thinking cap on when you watch my videos. Okay, so what we're after is the fuse in the power supply. So here's the power supply. There's the power supply transformer. There's the plug that goes in the wall. There's the plug on the back of the radio. There's some coils here, right on the power line. That's unusual. There's the on-off switch. I've been gained with the volume control, so what's that showing? Where's the fuse? Where's the fuse? Is it on the other side of the transformer? Like I said, sometimes there's a fuse in the... this radio didn't start up at all. Nothing happened. If you had a high voltage fuse out here and it blew, the tubes would still heat up. It would still draw power. It would have still done stuff. The light would have come on the front. Assuming the light is good, it would have come on. So, okay, so this is basically, this is a really bad sign starting at this point. I'll take that back. If this were the schematic for the radio and there were no fuse in it, then this would be a really bad sign that there's something wrong with that power transformer. Blowing fuse? Well, it could be saying the same thing, but there's no reason to think that. It's probably blue because you saw the condition of it. It looked terrible. It may not have even blown. It may have just corroded to death and stopped working. It would have separated inside because of the spring tension inside that fuse. Well, we're not getting any hints here at all. How about a note? Is there a note somewhere? Not likely. Not likely to be a note. Okay, and we'll just take a peek at the other half of the schematic here. Let me zoom in a little bit. And they're not going to find a fuse over here, I'm sure. I'm not going to find any notes, but look, we do have some interesting resistance readings. They've provided resistance readings on the tube pins. That's great. This is indicating 2 electrostatic speakers are in this radio. Really? It's a pretty small radio. 1, 2, they're in there. I see them in there. There's 2 electrostatic. Well, they may not be electrostatic. Yes, they will. Yes, they are. They are electrostatic speakers. Those are the tweeters. Chances are they're not working, but we don't know offhand. But that's not part of the problem here. It's just that, you know, when you start into one of these things, you're just trying to make all the observations you possibly can to get stuff sorted out. Up here is A, C, and B are test points for doing alignment. These are temporary resistors that need to be installed to achieve the FM alignment tasks that are required. Should we make it that far? Okay. How far wrong can I go with the fuse? Well, what if I put a big fat... I stick a penny in there. Suppose I stick a penny in there, no fuse anymore. I'm here standing with the radio. I know what I'm doing to some degree anyway. Could probably get away with doing that, removing the fuse. On the other hand, stick a big fuse bigger than intended in there, kind of by accident. So what? If I stick a fuse that's smaller, it'll pop. Make me think there's something wrong when there isn't. I think we can stick a 1.5 amp fuse in here. I could put a 2 amp regular fuse in here and carry on, something like that. And 2 amps may be a little big. That's what I'm going to do though. Got to dig one out now. I got lots of fuses here to pick from. Most important thing is to get the right dimension. That's the right dimension. So the 2 amp. These are slow blow fuses. They have various ways of doing it. And you see there's a resistor right inside there. And then there's a spring. The resistor will heat up and melt some solder. And the spring will separate them. There's different ways of doing it. There's one, just a spring. And it looks like a little pile of solder right there. Again, it'll heat it up and melt it. But we're not going to use that. We're going to use one like this. Now, this is a 3.15 amps. Sounds a little high to me. 2 amps, 250 volts. This is the guy. I don't know if you can see inside. Focus is a little bad. There's a little ball inside. I think what's going on there is there's 2 links coming over and they're soldered. And again, if you heat it up, the solder will fail. I think this is not a slow blow type fuse. Pop this in. Plug is out. This is a little corroded up here too. But we won't worry about it until we have to worry about it. There you go. There we are. Now, this time when we start it up, it's going to be a little more serious because something's going to happen. Either the radio is going to start in some fashion, or the fuse is going to pop. If the fuse could pop, we'd never even know it popped. I don't think it's going to make any sound or anything. Okay, get this out of here. Power's off. Plug is in. Volume set. We're on broadcast. I'm going to try again with the off button. Just occasionally these radios cannot be turned off. The on-off buttons are often trouble, I find, in these push-button radios of this sort. Not lately, but in the past. Here we go, power on. Nothing happening, excellent. 117 volts. Let's push this button this time. There we go. Oh, you didn't see the lights. Gotta see the lights, Jim. You missed that. So there they go. They're going down. As predicted, now they're going to come back up. And we should start hearing stuff. In the meantime, the panel light has come on. Okay, these lights are not coming up. Let's give it a little more time. I've got it on restricted power. You know, it's running with... Hey, what do you know? She's fixed. All done. That's the end of that. There you are. Who's new? Well, we can tune the AM, but we can't tune the FM yet. Let's just see what we get. So 55, 60, right here on the civil defense marker, we should find a station. Well, that's good. It's picking up the noises that are commonly here. Should be a station right in here. Bingo. So it has a directional antenna. We gotta get the right direction. Here we are. Well, okay, so this answers many, many questions now. What about the magic eye? You can see something going on up there, a green dash, and another one over here. Something not quite right there. Let's watch the eye in tune. Well, it's doing stuff. I think it's doing the right stuff. Okay, let's keep going. Too much interference. Now, there's a French station at 860, which I like to use to judge whether a radio's doing the thing or not. Let's see if we can get it. There it is. Okay, that's not bad. That's not bad. Shortwave with no antenna. So sometimes there's a way they connect the shortwave antenna to the FM antenna just so you have something. But that's not much of anything. Let's put a better antenna on it. Back. You know, first I'm going to check the FM, then I have to go and deal with some antenna switches to do the shortwave. So we'll go up to FM. Turn the volume up a long ways to hear the hiss. Now, I don't think we can tune it. No tuning action at all. What's going on there? What's that? Like a gear. Bump, 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 bump. Okay, we won't play with that anymore. We know what the problem is. The hiss is a good sign. There's something going on. There's a bit of green in that too. Okay, so we're going to check out the shortwave band. If the AM is working, AM broadcast, the shortwave probably is too. I have to stop and go throw some antenna switches first. Okay, so I have an outdoor antenna with a very long circuitous lead that makes it all the way to my shop here. Antenna on the left, ground on the right. But it's a fairly good antenna, so it tends to... It's a good antenna, actually. Okay. As my antennas go, it ranks as a good antenna. Maybe as antennas go, it's not so good. So I'm going to hook up the one side right to the antenna input. I'm going to leave the ground off for now. Put the ground on in a moment. I just always like to try both ways. Okay, so we're going to broadcast to make sure everything's the same way. Shortwave. Volume's got to be turned up fairly high there. Sounds like a radio though. So this has a band. The band runs all the way from 6 megahertz up to 18. That's a lot. That means a little bit of movement of the pointer, and you're moving quite a distance through the spectrum. So you can easily go right past the stations.
We won't read it today. But in Exodus chapter 6, verses 6 and 7, God gave 4 redemptive promises to Israel while they were in bondage in Egypt. Right? And obviously God...
Okay, so that's probably 9.330, and it's in the right spot on the dial. The reason I know that is it's a often religious programming, and it's very, very strong at this time of day. In fact, that might be the only thing you're going to get. No use going lower. So quite a strong hum has come in. Okay, when you tune in a station, a hum comes with it. That's an important observation. We'll go up in frequency. So the bands are marked here. A little hard to discern. .31-meter band. This is a funny name. 25-meter band. So I think this is around 11.4 megahertz, what I would tend to think of this as. Nothing much. It's kind of academic going up here. What's all that interference? Coming from my LED lights in my shop. Can you believe that? It's a little power supply. I run my LED lights. This is one of the lights here. Not the greatest lights by any means. I have a variable power supply rather than plug them in the wall to get rid of the interference causing wall wart that power these two lights I have in here. So I drive them from this. But if I turn this up a little too high, that's what comes out of them. Okay. That was a hard lesson learned some time ago. Okay, I won't go into that in any more detail. Let's carry on. Getting up around the 19-meter band, 15 megahertz. We should get some stuff here. Nothing. And we're not likely to get anything higher. It's not picking up stuff at 15. Okay, so what we've got a radio that works. Performance not so great. FM dial cannot be tuned. Seems like the FM side is working too, but the FM front end on these radios, the FM receiver circuitry is quite different from the AM and shortwave. It's a separate thing. And you know, I just realized I've still got this thing running on restricted power. Whoops. Hey, let's try it with full power. It's only 90 volts. That's barely enough. Let's give it a go here. Now, probably all that's done is make it louder. Really? Won't have done much else. Hasn't made it much louder. But it won't make it tune any better. Yeah, these are tricky. Little tiny knob. Like if it had a big knob, you'd have an easier time tuning with precision. So this is not your go out and hunt down interesting shortwave type radio. Meanwhile, this green thing seems to have changed here. Let's take a better look at that. Douse a few lights. You can see what's going on in there. Looks like a weird, that's kind of a weird shape. Oh, what was that? That thing just went and seemed to get a little bit louder. If you're watching the eye now. So can you see it's getting a little bit wider as I tune stuff in, even if it's just a noise signal here. I'll try and find that station. Very tricky to tune. Yeah, it's definitely doing stuff. So maybe this eye has a different presentation from the ones I've seen. Where'd he go? That nice station. Gone away. I thought it was right here. My gosh. The other thing is you hear the heterodyne tone. Hear that tone? Going down in frequency. That may or may not be of something of interest with the radio. Now what I'm going to do is I'm going to attach the ground here. And we'll see what happens. Drop the volume a little bit. Watch the eye. Signal itself is disappearing. Well, I saw enough to know that the eye is responding. The weird shape must be the kind of tube, and I'm just not familiar with it. Very good. Okay, fantastic. So it won't be I don't think it'll be a very difficult thing to make this radio perform well. But then I say stuff like that all the time at the start of these, and then things get complicated afterwards. Great. Switch off. Off switch works. Next stage is to extract the chassis, maybe dust it off a bit, and take a look at the capacitors, what kind of capacitors in this radio, and decide what to do about what. Yeah. Okay. Great. Okay, so I've tipped the radio over to get a look at the bottom and figure out what screws might need to be taken out. Very interesting. So a lot of these radios have an open bottom with a cover. This is the cover, which we're going to remove. And it's hiding the screws that are holding the chassis in. But I think the idea was you don't need to take the chassis out to do work on these radios, because you can get access to the parts through this opening here. A lot of these have metal foil on them. They have a wire coming that has to be hooked up into the radio to ground the foil to provide some shielding. Doesn't look like this one does. And sad thing, in the last few minutes while I was away from the shop, I just discovered that the drummer from the band Yes, it's really my favorite musical band, just died. Died a couple days ago. It's a guy named Alan White. Yeah. So okay, there's the tin foil. There's the wire. And a bunch of dust fell down. Now there was something loose in here. When I turned the radio, I heard something fall. So let's see if we can find out what that is. Yes, we can. Well, it's not the best thing in the world. It's a piece of broken plastic. Okay, well, I'll probably be able to sort that out in a while. So, hey, lots of access here into this radio through the bottom. Lots and lots of access. Let's take a look before we pull it out. So this guy's got some, what I've experienced, or within my experience, I would consider unreliable capacitors. It's this style here. You can see another one here, a couple up in there, one here. Not too many. One buried deep in there, which almost certainly I cannot get at. Sometimes you can put a new capacitor and leave the old one behind. And you can put the new one in a slightly different place, but there's a risk in doing any change at all in a radio like this, especially if it has FM in it. Moving any of the wires, now down in here maybe not so much, but certainly other parts of the radio, just moving a wire will cause a tuning change. Looks like I can see access to tuning items in the FM tuner. Must be in this box here. Where? Here, where I'm pointing. So there's access for doing tuning adjustments. Over here. And that's got to be the FM box there. What about this string? Well, what about the fact that it doesn't tune? Let me turn the tuning knob on the front. We're just going to watch something here. You can see this turning here. So this is turning probably a large capacitor in here. And that's... Okay, I have to turn these knobs separately here. This hurts my back, my poor back. I think I have a rib out of place. I think that's what's happened in my back here. Okay, holding one knob, turning the AM knob only. Okay, so that wheel is not moving down there, is it? But if I turn the FM part there, it moves. So that's odd. That means the FM string is going. How come the pointer doesn't move? That's a little hard to sort out with the chassis in. Okay, so having taken this plate off the bottom, the cardboard plate, we now expose these other screws here, which I can take out. I got the radio on its side, so I'm going to remove the lower screws. They can hang from the upper screws. Something just fell. While I'm doing this, my eyes are running all over this, just looking for anything that might leap out. What might leap out? Something burned up. Which I don't think there's anything like that in there. Where did my cup of screws go? He's lost his cup of screws. Set them there. I can take... Oh, look at this one up here. Not tight, not tightened up. Why would they leave this one loose? Just by accident? Probably just by accident. Okay, last one. Take the last one out. I'm going to have it hang over the edge here. Bench. Just try to to feel my way to doing it. There we are. Okay, 4 screws out. The great thing about these radios is the dial and knobs and buttons and everything are on the chassis. So it all comes out. Except this magic eye is might be clipped to the... It is. It's clipped with a fair bit of wire. It's got quite a long length of wire, so we shouldn't have to worry too much about it. Start this moving out. A little bit at a time. Feeling for any restrictions. Yeah, it's a kind of a dumb arrangement. Can you believe it? You cannot pull this radio right out. It's wider than the cabinet. So that black wheel we were looking at is here. It's behind the edge of the cabinet. So this must be a swinger. It must swing this guy out. Doesn't look possible to me. And I might just... I've got to get it to work. Everything is a challenge here. Maybe if I move it over to the right. Wow. Yeah, it's just going to make it. You're using every available millimeter here. Come on, out of there. Something restricting it. So the speaker is staying behind with wires. Magic Eye staying behind on this cable. Speaker staying behind on this cable. So lots of cable, lots of wire. Come on out of here. Why does it not want to come? Is that little wire underneath catching on something? Where did the little wire go? No, it's down at the other end. It's not catching on anything. Some pretty fragile stuff here. Look at this stuff up here. Very fragile. So this can easily be a destructive moment here. Oh my gosh. You know what's going on? Somebody know what's going on? This is crazy. There's a component on the side of the radio here that's... Oh my gosh, it's just, we're talking millimeters here. Not even less. Now I got the glass. The glass is actually bigger too. Okay, let's go back to this side here. Okay, we got it. Now, the way I think they want you to do this is just kind of pivot it and leave half of it kind of hanging inside. Yeah. Yeah, okay, so we've reached the limit of this. I'm going to have to take out the magic eye. Should just be clipped in there. Looks like I could just yank it out. Wow. I'm yanking on that. Okay, so it's just a metal clip. Okay, another way of doing this, I leave the tube in and just take the socket off. Maybe I better do that. Okay, we'll do that. Oh. One's done. Now the speaker situation. Because it's got electrostatic speakers, there's going to be a couple of extra wires here, and probably probably not a plug involved. Yeah, it's wires everywhere. Ay, ay, ay. Okay, but with the magic eye, maybe I can rotate this way. Untangle it. Hey, got it out. How do you like that? There we go. It's a process. I think I got it out without doing any harm to anything. Still have the speakers connected. So we can see a lamp cord style wire going up to the main speaker, coming off of what is the output transformer here. Then we can see two more. We can see this wire. This wire's going to a connector here. And then this wire, this green wire, which is the one that's pulled taut, that's what's restricting things here. Okay. Green wire. Okay, glass is loose. Camera, what are you doing there? The green wire is coming from down in the chassis near the output tube, coming up and attaching into this. I'm going to guess that this is really just a ground wire, this one here, and that this is feeding the signal that goes to the electrostatic speakers. The thing about this is this has a couple hundred volts on it. So everybody who does this kind of stuff casually knows that speakers can't hurt you, but that's not the case in these old radios. There's two examples where the speaker can be dangerous. And one is electrostatic speakers, because of the high voltage. They have plate voltage on them. Could be a couple hundred, 300 volts even, I don't know. I think it's typically around 100, but I'm not sure. And the other one is, in the old, not in this radio, but in other radios, the speaker doesn't have a permanent magnet, has a coil in it, and the coil is energized at high voltage. And so, especially the big old radios, floor standing guys and all that, danger, danger. So when I was a kid, I realized somewhere in my electronics career as a kid that the speakers are low voltage things, and I never understood the speakers with a field coil in them when I was a kid. Okay, so when I pulled this out, I pushed this resistor quite a bit. Didn't do anything though, it's fine. That's a 470K resistor. That's very important in the operation of the eye, proper operation of the eye. Okay, now I got it out. What am I going to do now? So, examination time, and get familiar. Looking for things that I can accidentally break pretty easily, like I've already spotted a few. You know, this whole piece is high up in the sky. All this stuff's high up in the sky. And you get shock cords caught on it, all kinds of ways to damage it. That's a pretty interesting piece of wire. It's got three leads in it. This appears to be bent forward, but who knows? I mean, maybe I got a whack sometime earlier. This is the ECC 85. This is responsible for the strength of the FM radio to a very large degree. Light bulb, good. Couple capacitor there. That's easy to do. What's this big electrolytic one doing here? Got a terminal on the back, and then two here. So it's a double capacitor, two-part capacitor. Red wire, one of the wires going to the output transformer. So this is a pretty strong hint that this is the power supply. Filter capacitor. Is there another one? So these two are IF cans. They're not filter capacitors. Generally, those are put up on top because they're large pieces. That's why it's up here. And usually in an old radio, these guys got to be changed out or you're listening to hum. There was a little bit of hum in this radio. Another thing worth noting, this guy right here. So pretty sure this is the rectifier, which is responsible for producing the high voltage DC. This is a solid state component, an early one. Maybe that's not the right word for it. It's a type of rectifier I don't think would be used anymore at all. In North American radios, this type of rectifier generally is highly unreliable. In European radios, it doesn't seem to be quite the case. They seem to be much better built. Look at this thing. It's very rugged. Big metal brackets around it. I'm not naming the type of rectifier it is because the word's not coming to mind right at the moment. It's not a silicon rectifier. Made in Germany, it says on it. So this is an important component to pay attention to in a radio like this. And the question is it getting hot? It's going to get a little bit warm, but is it getting hot? If it's getting hot, maybe it's time to change it. Word on the street is one of these guys blows up and your house is full of terrifying smoke. Now what's the problem with the pointer? Let's see if we can sort that one out. First problem is these two knobs are kind of locked up a little bit. They really should be turning independently, I think. Why am I... So, just from this angle you can't see it, but you can see the pointer moving over here where my finger is. And you can see the tuning capacitor being operated. Here's the tuning capacitor for FM. Notice there's only a few plates on an FM tuning capacitor. Funny, they've canned the AM one, they've left the FM one out in the open, which is just a little unusual. What is it? Is it stuck? So what can happen is you see there's a shaft going through a sleeve here, and this is some kind of cast metal. You can get a situation where this freezes inside here. And I think that's the situation. Let's try turning it. So it's extremely stiff. That's probably the only real problem here. So I'm going to put a little lubrication in here. I'm going to use my good friend water displacement number 40. And we're just going to give it a little dab. It won't take much. A little dab, and then we're going to try to do it right in here too. A little more. There. Turn this, and chances are it's just going to loosen right up. There's more bearings in here. I can see the pointer moving. So if we get this working, it's looser, but it's still very, very tight. Very, very tight. Remember I heard some thump 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 sound? What was that? Thump thump thump? Was that this skipping over that? So there's bearings in here on this shaft, but these are more point bearings, so they're not likely to cause drag. So I'm feeling funny things here. This should just feel as smooth as can be, but there's a something is rubbing on something, or something is happening here. Let's try the front dial now. We're getting nowhere with the front dial. Okay, I'm going to turn the front dial and help it at the same time. Both knobs are moving. That's why you're seeing this. Turn. Well, it's as if there's absolutely no traction coming up from the tuning knob on the string. As if it's just got no grip. And I think it really has to do with this is just requiring way too much force in here. Making some funny sounds. Okay, so I'm going to throw a little lubricant into the parts here. Ooh, that's a lot more than I was aiming for. And over here, We have an anti-backlash gearing mechanism. There's no good place for me to shoot any lubricant back in there. Oh, maybe up under here. Yes, there is. And get right on it. Okay. Now the string works its way through quite a number of little pulleys. Like there's one over here. But generally, those pulleys have no propensity to have any friction in them. Not necessarily, but let's see, so the string is basically it's a complicated string mechanism in here. A lot of these German radios, if you should get one with the string broken and kind of pulled out, if you don't get a string diagram to sort it out, good luck to you. Good luck. That's what I would say. So, and they tend to have not only the string pulling the pointer along, they tend to have supporting wires or strings. And there's one in here, this piece right here. You can see the pointer is kind of going between them. This is just a very taut piece of feels like a plastic guitar string is what it feels like. Well, again, there's absolutely no back friction there. Well, FM radio's not much good if you can't make the tuner work. Okay, so I just understood what that sound was. As I turned it, I had my finger here. I could feel the string pop. So what's happening is, change the angle here. So this wheel is grooved. This one is grooved for the string to run in the grooves. And when you come across this gap, the string doesn't settle into the groove at first. It rides up a little bit. And then it falls into the groove. Don't pick at it, champ. Don't pick at it. The last thing you want to do is encourage a break anywhere in this string, because lots of tension. And tension's provided by a spring that's stuck in there, and there could be more springs. Maybe not, but there could be. I'm just hoping it's just going to loosen right up, but so far, not so. So in a system that's all connected together like this, it is a little hard to tell just who's the laggard in the system. So for the sake of eliminating them, I'm going to have to lubricate these, or somehow turn them and become convinced that there's nothing wrong. But I'm not going to use WD-40 there because the spray is too uncontrolled. Instead, I'm going to use just some oil. I'm feverishly looking for right now. Where'd it go? Here it is. Here it is. Here it is. Here it is. So I have an oiler with a little tiny needle, like a needle they use to give you your shots. Put a very small amount of oil right in here. Likewise over this one. Just a little bit. And there's got to be something hidden underneath. We haven't looked underneath. We have not looked underneath this radio yet. Okay, so what's the best way to do that? Because these wires are, restrictive. Big transformers here, so this is the heavy end. Oh, it looks to me like you can easily tip this up quite securely on its side here. What's this little piece of wire sticking out? That's another, it's not wire, it's this stiff fishing line material used to support the lower pointer. So it's not a problem. There we go. One of the things I keep in mind, and if you watch lots of my videos, you know this, is that everything I do runs a risk of breaking something. Oh my, I didn't mean for that to happen, but it's too late now. So every little operation, nothing happened here. Every little operation is a little bit scary. I've got this up because I'm looking for more FM. I might as well do the AM pulleys too. I think this is an FM one. Yeah, because the string's not moving. So here's another pulley down here. Jim, what'd you do with your oil now? There it is, way over here. My guess is these are never oiled out of the factory. They just, the plastic on the metal shaft is good enough. Increasing the, oh boy, look at how this is done. This is not friendly at all. So it has this metal bracket arrangement, and inside it is the end of the tuning knob with the drive pulleys. How in heaven's name would you ever get at that? Oh my gosh. Why would you want to get at it? Well, one solution for a slipping string is to loop it additionally around the tuning shaft. That's pretty much impossible with a radio like this because it means redoing the string and everything. But getting a look at it might be helpful. But we're not getting in there. That's we're not welcome. We're not welcome there. Look at this arrangement. Screw here. Shaft going down. Well, I guess what we can do is carry on. Yeah, we're looking underneath here for the first time too. Let's do that. Okay, so FM's not going to be an easy solution. Maybe the lubrication I put in will become more effective over time. Kind of doubt it. It's still very, very stiff to turn. Crazy stiff. Has an anti-backlash gear system right here. Not really backlash, but play. So if you can imagine, you put gears together, there can be a little bit of play. If the gear is driven in one direction all the time, like in a car or something like that, I guess they reverse direction too, but if they're driven in one direction, then the gears just stay pushed. But if you're going back and forth, they will travel through the gap to get to the other side of the gear. And that'll feel in the tuning like there's nothing in that. And you tune and there's nothing. It's like play in the steering wheel. Same kind of thing. Well, that's unattractive. And you're going to try to sell these radios in a store. It's a lot of, how's it look and how's it feel, how's it sound, all that stuff. But the feel part is important. Push these buttons, turn these knobs, how's it feel? So this is all part of, I guess, the design of the radio, and its need to be marketed in a competitive marketplace. Right, so we're going to look through here. So first off, a lot of parts in these radios. The German designers did not hold back. A similar radio made in North America would have a third the parts in it, probably. The advantage of all these parts, I think, is you get a higher quality of sound. I think they do achieve it very much in these radios. They pay a lot of attention to high fidelity. So you're going to pay $1 for a radio like this. And it is full of those unreliable capacitors. Now I have another radio I'm working on, I just set aside just now, that is also full of these capacitors. What I did in that case was I've identified the critical problematic capacitors that really, if they leak even a little bit, it's bad news. And I've changed those. And maybe we're on our way to the same thing with this radio. The problem I'm having with the other radio, and I think I'm going to have with this one, is that it's largely working. So trying to do things to improve its performance is pretty difficult if it's already performing fairly well. But there are some of these which are fairly critical. The wild guess is this blue one down here that I'm pointing at, is electrolytic, small electrolytic, or one like it is going to be involved in the FM detector circuit and will probably benefit from being replaced. A lot of these are involved in the audio side of things. They're not maybe as critical as the ones that are in the radio side of things. We also heard the hum when I tuned to a station. That can be an indicator of a particular capacitor, the one that's on the power line, believe it or not working well. Whichever one that is in here. Otherwise, this looks to be in great shape. While I'm sitting here talking, I'm looking everything over, trying to spot anything that might really jump out at me. And no, there's nothing jumping out of this radio. Lots of very light wires in some places that'd be easy to break. Don't want that to happen. Can also sometimes, off of the volume control, the capacitors involved are special shielded capacitors, and I think this is not. This is not a special shielded capacitor. You can tell them because they're regular looking capacitors, but they have 2 wires out one end and one out the other. And the one wire actually just goes to a shield. And the reason for that is this is a very sensitive area audio-wise, so any little bit of stuff get into there, it's going to come out the speaker. And I don't stock a shielded capacitor, that's why I'm looking to see if that problem exists. The real problem with this radio is you cannot tune the FM. That's really the highest order problem. Everything else is rather secondary, I think. Another thing I can do here is I can pick one of these capacitors, like I might pick this one because it looks so easy to do, replace it, and take this capacitor and test it. And the results of the test give me some indication of what to expect with the rest of them. Generally speaking, though, it all looks pretty good. Make sure I'm grabbing it somewhere safe here. During the risky process. Okay. Maybe to tune FM, you're going to have to reach in the back of the radio and reach on top of all this stuff. And then that can't happen. I'm talking about light wires that can be broken. There's a bunch here. Where are all the push button wires? Were they underneath? I guess they were. These radios with the push buttons on the front panel often use the all the terminals on the push buttons, here they are here, as places to build the radio. And that's exactly what's going on here. See, all these components are soldered right into the switch terminals. This makes things really difficult. A lot of these terminals are not used for anything, so they're just available connection terminals. So the designer will utilize it, hook up a couple wires to it. You think those wires are hooked up to something down here, but there's nothing. They're just hooked together and usually using the terminal. Very confusing. Schematic doesn't reveal any of this, although I think there's a diagram showing component placement, which can be helpful. The adjustments for tuning up this radio, one here, this is the capacitor here. These have wax board in them to keep busy fingers away, like mine. That's a problem. If in the end we think, oh, this radio needs to be aligned, got a little bit of wax there to worry about. The alignment of the IFs. Okay, so there, I don't think they're waxed up. Here's one IF down here, the other IF transformer up there. That part I think can be done without too much trouble. If it appears to be, if it appears to be necessary. Okay, so the order of business is there was a bit of a hum. So probably augment this capacitor or get rid of it. See if that doesn't knock the hum out. There wasn't a general hum though that I could hear. I should probably run the radio again in a bit. Glass here is loosey-goosey because the little rubber mounts that were in here have either fallen out or given up the ghost, or they're gone. There was some rubber bandy sort of material. Here's a bit right here. This is probably the material that was in here, keeping the glass fixed in place. You can probably do something very simple to fix that up. You may want to take the glass right off on this radio anyway, and for cleaning, and also to get access back in here if in the end we're just getting nowhere at all. Now, why is it these two are locked together? What am I talking about? I'm talking about these knobs here. Why are they locked together? Well, if this isn't gripping the string a lot, then it's freer to be dragged by this knob, and they're just in contact here. I think they're in together too tight. That's what I think. That's a little too big. Oh, screw on very tight. Okay, we'll pull the knob forward. No, still wants to take it. Well, we can't have that. Take that knob off. We'll take this one off too. Oops. Hard to see the screw in there. There we go. Oh, there's a little foam piece. Felt piece. Okay. What the heck? It's one knob. There isn't two knobs here. Why the heck would they do that? Is this supposed to pull in and out? Oh, so some German radios, when you push FM, yep. Okay, new issue. Maybe this is where the solution lies. So a lot of these radios, when you push the FM button and the AM button, when you go back and forth, you're causing a gear change to take place in the drive system. And the single knob drive is being delivered either to AM or to FM. And it usually involves a piece moving back and forth. If you look down here, let's get a little more light on it. Kind of look just under where my finger is. And I'm going to push the AM. See something pop back and forth? That's the gear drive, and that's what I felt thump, 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 thump when I was doing this, and I could feel something that sounded like gears bumping over it. That's what it was. Now, this piece may not be going properly. See how it should only be moving the AM, which it is. Now we put the FM. It should only move the FM. Oh, it's doing it. What was the problem? What was the problem? Fixed it. No idea why this has suddenly started working. Did I not have this button down all the way? I mean, the beauty of this is you can then tune your favorite FM station, and when you go back to AM, it just stays tuned to the right FM spot. Well, this is working right along now. What happened? You know what happened? I was closing in on the problem, and the radio knew it because it's sitting here listening to everything I'm saying, and it knew, oh, the jig is up. Boys, I might as well just surrender. Pretty stiff compared to broadcast. And it's fairly stiff too. Okay, we're in business. Let's play this radio on FM. Now, I don't have the Magic Eye tube plugged in, but it won't matter. It's not a element of the operation of the radio itself. And we still have speakers connected. I gotta plug the FM antenna back in, or we're gonna get nowhere. Yeah, great. Fixed another thing without knowing what I did. I didn't even get to the point of threatening it or anything. Very sensitive radio. Okay, we're in broadcast mode to start with. And we need to plug the power in too. It's another important element. Okay. Volume is down. Power through the dim bulbs. Okay, you can see a little dim bulb flash. For a moment, all looks well. I'm going to give it full power. Pretty bright light bulb here, blasting away. Maybe I can just shut it off for now. We're on broadcast. Come on, radio. Did I break it already? Do you need the magic eye? I can't imagine that. We got nothing. What happened? We got nothing happening. Speaker wire's still connected. Why have nothing happening? We have 117 volts. Zero happening. Jimbo, what did you do that you don't realize you did? Short-lived radio. Let's go shortwave here. Does it need the magic eye? It's the only thing that's not the way it was. Should be very careful about this thing hanging out here too, because it's got some high voltages on it. It's just flopping around. What did I do? Well, I have to plug the magic eye back in. I don't know what else to try. This is a little odd. This is the thing about working on other people's stuff, by the way. If you're working on your own stuff, you know, there's no need to shed tears at any time, but if you're working on somebody else's stuff, look at this situation. This is terrible. This is terrible. Come back up. Go back. Go in this way. Hey, let's get the tube out now. That's the way to do it. Get the tube out. Get the tube out of here. Let's just increase my safety. Hey, what's going on with that camera? Autofocus just doesn't. Okay, I'm going to try to release the tension on the clip. Shove the tube. There it comes. I can't imagine that this has to be plugged in for the radio to work. Jim, could be charges floating in here. Okay, this guy's back in, but I just can't imagine that's going to help. I need to further improve the safety here. I can't keep my eye on everything. What I'm going to do is we're going to bag this. Yes, the bag's going to melt. Okay. Now, if sound comes out of it this time, I'll be weird. Okay, here we go. Unplugged it. Here we go again. Whatsoever. Not a thing. There's no hiss, no hum, no crackle. It's as if there's no high voltage in the radio. Something popped just while I've been working here. So we're going to look and see what the B plus is. Pretty sure it's going to be on this red wire over here. Nothing. How about here? Okay, maybe I got it wrong. How about here? There is no high voltage in this radio as of now. How did that happen? How could that happen? Tubes are all in place and glowing. Magic Eye's getting ready to melt the bag here. Oh my gosh. This is one of the main reasons I like to start these guys up as early as possible in the process. Find out what's going on. See how much they perform, because as soon as you start doing stuff, things change. If you didn't know what the state was when you started, you're a lost puppy. Sure looks like it's chassis grounded. The meter is showing nothing. Meter is showing 0. The fuse is there. I can see it. It looks good. Voltage is 112 volts. That's a bit of a bad sign too. Because let me turn this off and see what happens to this voltage. Oh, the dim bulbs are still in the circuit. Wait a minute. Hold on a second. How are you getting 111 volts with the dim bulbs in? that means the radio is not drawing very much current at all. Well, if there's no B+, all these tubes are quiet. None of them are conducting current if there's no B+. Well, where would the B+ go? I'd like to swing this out a little bit. Here, let me cut the power. Just kicking myself here. Did I do something and not forget what I did? What did I do? I didn't do anything to it. I haven't done anything to it. So we should have a high voltage here, I believe, coming out of this transformer. Okay, power back on with the dim bulbs. We'll read the AC voltage. Figure out how to do that with this meter. Where's the AC? This is a new meter. Was given to me by a viewer, a fellow named Alan, and it's been working very good for me. Maybe this is the first time I've tried measuring hertz. Well, there it says voltage. What's the hertz there for? Hertz. I don't know. Okay, we're on AC anyway. We're good. 600 volts AC. Making a big deal about nothing. Okay, let's turn the light off. So we'd be looking for something on the order of 300, 400 volts. Who knows? Let me swing this around a little bit here. Better access to it. 4 volts. The other thing about this is whatever it is that's happened could unhappen at any moment. And the thing can come to life. We got the volume turned right down. Could come to life and scare the bejesus out of me while I'm in the middle of doing something. So, well, something weird has happened. No, I mean, is it possible this fuse is only on the high voltage? Is that possible? No. No, because with the fuse blown, the original fuse, nothing happened in here. No lights, no nothing. The tube has come loose in its socket, and if I just push it a bit, everything will be good again. It'll be the output tube. Watch it, man. You're going to get a shock for sure. It's just no sound whatsoever. How can a loose tube cause a B+ problem anyway? It can't. Let's try this again. So I'm guessing here. That's a very good guess. These two terminals, one has a red wire and the other one is grounded. These two terminals have... Oh! Look at that! There it is. The wire broke off. Power down. Well, maybe when I had the radio tipped up on its side, it broke this wire off. Power off. Okay. There we are. That's what the problem is. Okay, we'll fix that in a moment. 55 minutes of video. Yikes. Okay, let's keep her rolling here. These are really, really light, like really light wire. I don't know if I can do it with this little tool here. Yep. Wow, it's just about nothing there. One tiny little strand. This could be the same wire that's in the winding of the transformer. Man, no wonder it broke. There's nothing to it. Okay, let's get it on here. Just switching on my soldering iron. See, you probably can't even see the wire in the camera. It's so fine. I can't see it either. Just need to tuck it in behind here. So if this is actual winding wire of the transformer, been brought out as leads, then you don't want to monkey with this too much. Okay, I think that's good enough to solder. There, this isn't the best connection, but the wire is so incredibly light. Oh, don't do that. I have to apologize for the sharp sounds that are on my videos. Okay, here we go. Plugs out, power's off, everything's good. Light is poor, light is poor. Okay, might be a little too much for the camera, but good for my eyes. Okay, she's hooked back up. Remember I said about without realizing it, you can break stuff, things can happen, you didn't know you did it. It's a beautiful example of exactly that. Exactly that. Okay, this time it's going to work. I'll put some money down. I don't have any money in my pocket, so I have to gamble with an IOU. Okay, we're starting in broadcast. Volume up just a wee bit. Here we go. Let's get this going. Just want to make sure that the FM is working. And tune it. So we're starting with broadcast though. Come on, baby. Hey! Here she comes. FM. That's all we really need at this point. The pointer is actually up a little high. It's kind of out of the slot. It's barely in the slot. Okay, we're at the high end, 104. The better stations are down here. Stronger stations. I got my sign in 2009. You get it. Okay.
Thousands of mugshots of Uyghur in detention camps. The youngest is 15, the oldest is 73. In the photos,
just listen
some
for a moment.
Detainees appear teary-eyed as guards stand behind them carrying a baton.
I had a look almost half of the picture.
So I'm listening for the S's to sound like natural, not shh shh shh, or kind of sound, but nice, clear S's.
And it's just to look again and continue to look.
That's Trinisa Maxidi.
You know what? We're on low voltage here. Give it the works now.
For Uyghurs. Both she and Ilshat have lost contact with their families in Xinjiang and worry they may have been jailed. According to the BBC report, police recognize the slightest expression of Muslim beliefs, like not drinking alcohol, as a reason for Uyghurs in camp. The document's publication coincided this week with the UN Human Rights Commissioner's visit to Xinjiang. Trinisa and Ilshat told us about what it's like seeing those images and what they hope will come out of this latest revelation.
Great. Okay. Hey, that was exciting. Broke it and fixed it all in one session. Great. So I got a few things to think about, and mostly around, are there any capacitors in here that are worth changing, or are we already done with this radio pretty much, and it's in operating state and it will continue to operate for years to come, even as it is right now. There's a good chance of that. Great. Well, thanks a lot for watching this. A little bit of a long video, and we'll probably work at least one more day on this, maybe many more, who knows.